Hey there, everybody. Today I'm going to be teaching you all a little bit about MATLAB. What is MATLAB, you might be asking yourself? Well, it's a user-friendly interface that's designed to help us develop software programs and create graphs and to calculate some complex functions using matrices. So that's actually how MATLAB got its name. If you notice, MATLAB, it's shortening for Matrix Laboratory. So all the variables we type into MATLAB are treated and stored as matrices. And all the operations that are done on MATLAB are also treated as matrix operations. So this is a very useful tool when we're working in MATLAB. So there are a few major work areas here on MATLAB, one of which being this one we are in the center right now, called the command window. This is your main work area. Here you'll be typing in numbers, doing computations, and this is where all your answers are going to be shown to you. So for example, if I type in something like 2 plus 2, I get an answer of 4. Or I can type 5 minus 9, get an answer of negative 4. I can even do more complex things like 33 cubed, and you get the idea. So now we're going to look over here to the right. This is your workspace. This is the central hub for all variables you define in MATLAB. So if I go over here to the command window, and perhaps I'll write up a variable that says a equals 8. That variable a gets stored over here in my workspace, and the value of it, 8, is shown right here. The same goes true for values that you don't necessarily specify the variable of. So if I type, say, 2 plus 3, I get an answer of 5, and so that answer is stored as the answer variable, and the value is stored as 5. Now the thing about MATLAB is that the variables are constantly being updated. It always updates a variable to the last entry that you type in for it. So if I go back into the command window right now and change it to 3 plus 4, now I've just updated the answer variable to 7, as you can see over here. The same holds true if I redefine my a variable to be, 4. Now my a variable has been updated as well. So if you're going to try and use MATLAB, you want to make sure you're keeping your variables straight because they're always updating to the most recent one. Over here on the far left now, we've got the current folder. And as this name suggests, it's basically a collection of all the different file folders that we have here on MATLAB. You can save all kinds of different things, ranging from programs and functions and variables, and they can be saved here in this folder for you to essentially use as a grab bag to pull up in later projects. You can even go back as far as like your documents and search for other file folders should you want to store it somewhere a little bit more different. Lastly, we've got up here in the top left this new script button, and that opens up a nice little editor for us. This is basically their blank slate for writing programs from scratch. I can write up just about any program I can think of, and then I can save that program to the current folder. And then those programs I can pull up later in MATLAB, and we can do a little bit with them and use them to do more complex calculations. But we're going to save that for just a little later. Right now I think it'd be cool if I showed you some of the built-in functions that MATLAB has to offer everyone. So a really nice function is this CLC function. And it's really great when you've cluttered up your command window, like I have right now, because CLC clears it right up for you. Other cool things we have here is you can type in PI and get our good old classic pi. I can also press my up arrow key. And what that does is that gives me a list of all the different things I've typed in up to this point. And I can hit a left arrow and bring back any old friend, like 33 cubed. And in that same list, if we scroll up way up to the top, way up to the top, way there. Okay, so as you can see, it stores and timestamps all the information you type in a day. So like, if I came back in at a later date and I want to know when I typed something in, date and timestamp are all right there for me. So that's really cool. Let's see, other functions we can type in here are the whos function, which is really nice. If I type in a equals 8 and then type in whos, now I get a detailed information box of all the different variables I have right now. So I've got my a variable and my answer variable. And those two are both being treated right now as 1 by 1 matrices, as you can see by the size here. hence emphasizing my point that everything here is done as matrices. Finally, I'm going to show you the clear all function. And clear all erases all the variables over in your workspace, so you can start with a fresh, clean slate. Now, you may not always want to delete all of your variables, so you can specify a single variable, so like in this case, clear A, and now my A variable goes away. Similarly, I can type clear all, and it clears all my variables out of the workspace. Then we're going to go ahead and type CLC one more time, clear our command window, and now we are ready for a brand new fresh start on MATLAB. So the main thing I thought would be cool to show you guys is to show you the matrix applications that MATLAB has. So let's start off by defining a matrix. And I'm going to show you a simple, I guess, 3x3 matrix here. So matrices are defined by these brackets here. And for my first three terms, let's go 1, 8, 9. So this is going to be my top row of my 3x3 matrix, and you want to put spaces between your numbers to differentiate them. Then you put a semicolon, and that shows a break between rows. So that's the end of my row 1, and now I'm going to jump down to row 2. So now we'll go maybe 2, 7, 6, semicolon, and then maybe 3, 3, 3. Now I hit enter, and I get a beautiful 3x3 matrix. So that's a really cool function we've got going on for us here. And another really cool function that we're pretty familiar with right now is A transpose. So if I take my A matrix that I already established, and I slap an apostrophe right behind it, now I actually get A transpose right like that. Super quick and easy. And since we can use A transpose when we're dealing with our inconsistent systems, I thought it'd be cool if we write up a program real quick to solve those inconsistent systems for us. So let's go ahead and do that right now. I'm going to clear out all my variables real quick with the clear all function, then clear our command window, and now we're going to go open up a new script. Alrighty, so when writing a program, it's similar to how you would type in the command window. We just need to type in all the things that we would want to see. So the first thing we have when we're dealing with our inconsistent systems is an A matrix. So I'm going to set up an A matrix, and I will set it equal to a problem we did in class already. So that's going to be 1, 1, 1, -1, and then 1, 1 again. Then, if I put a comma in, I can set up our second matrix we're going to need, which is a B matrix. Alright? And in the same problem, our B matrix in this case was equal to 2, 1, 3. Okay, there. Alrighty, so now I've got those two matrices set up. So then I'm going to hit enter and enter again, because it's always good when you're programming to keep some space and keep your thoughts straight. So the next thing is, what's the first step in our inconsistent systems problems? It's we take A transpose A. So if you remember, A transpose, we just show by the A matrix and then an apostrophe. And then we're going to multiply it by A. Now, this is the value we're going to want. But if we want to save that number somewhere, we're going to have to set it equal to a variable. So I say we define this as a C matrix. Then, the next step we're going to do is very similar to this. It's A transpose B. So this time, we're going to set A transpose B equal to our D matrix. So let's set it just like the last one. Alright, looking good. I'm going to space out here and give us some consistency. Because now we're at the point where we can start getting our answers. So how do we get our answer for the least squares, or represented by x bar? We had to take the inverse of C and then multiply it by our D matrix. So I'm going to show that right now. We're going to call that variable x, because x bar. And it's going to be equal to the inverse of our C matrix. So C being put to the -1 power. And then we're going to multiply that by our D matrix. And then I think as an added bonus, we're also going to slap on the residuals. So if you remember what our residuals are, the residual was the B matrix minus the A matrix times the x bar, or the x matrix in this case. So we're going to set that up too for us, because It's a very useful thing to have. So b minus ax. Okay? And I think we're looking pretty good here. Now, don't worry about orders of operations. That's all taken care of by MATLAB. Same PEMDAS that we always use. And I think this program's ready to run. So when we're ready to run a program, we come way up here to this green arrow button that says run. Oh, yep, we got to save our file here quick. So I'm going to save it as inconsistent. And then you'll notice that MATLAB files save with a .m. .MATLAB. Okay. Oh no, what have I done? Hold on. You know what? I changed my mind. Don't hold on. This is also really cool to know. Because everything in MATLAB is done like a matrix, obviously if the matrix multiplication doesn't work right, it's going to send an error message at you like I just did. But it actually does a pretty good job of identifying where the error was. So if you notice here, it says inconsistent line 4, column 5. So I'm going to go to my line 4 in my program here, and I notice, whoopsies, I forgot my multiplication sign. Tee-hee! Alrighty, let me look this over real quick, because I think the rest of it is good. I think we'll slap a multiplication sign in there just in case. Okay, now we should be good. Let's try that again. And bam! If you'll notice, I have it set to show us all the different variables that we set up as matrices. So there's our A matrix, our B matrix, the C matrix we would have gotten, the D matrix we would have gotten, our X bar, and our residuals. And if you go and compare that to the first problem we did in class, those are the same answers right there. So that's a really handy little function we've got there. So I know this one is one I'll be using and possibly editing later. And like I said, you can always pull them back up later and edit things in. You can even add comments in if you want to keep track of what everything is. So if I go up here and you type a % to indicate that you're going to be typing in a comment, and I'll say least squares here, and then maybe I'll add another line here and say residual. Super cool, right guys? Alrighty. Well, now that we've got some foothold here in MATLAB and a really cool program here, I want to say thank you guys for watching. Hope you enjoyed it, and maybe I'll be seeing you on MATLAB. Later.